Welcome to Module 2, the Chemistry of Wort. My name is Eric Steimel. In this module, we are going to continue what was discussed in the malt chemistry, where we introduce starches, sugars, and enzymes. Previously, we discussed our malted barley, so now we have our malt. The malt now contains a little bit of sugar, but it's mostly starch. We activated the enzymes, alpha-beta amylase, and we stopped that process by kilning, by heating. We need to restart this conversion and extract the sugars. The sugars we want for fermentation are glucose, maltose, and maltreose. Longer sugars are referred to as dextrins. So we need to make wort. What is wort? Wort is a liquid that's extracted from the mashing process during the brewing of beer. Well, what's the mashing process? We'll get to that. Wort contains the sugars that will be fermented by the yeast to produce alcohol. It will also contain the longer chains that add sweetness or makes the beer malty, the dextrins. So how do we make wort? Well, we start at the mill. We take that malted barley, we mill it or crush it, making grist. This exposes the sugars and starches that are inside of the husk. This also helps break up the starches, exposing more surface area. Then we mash. We add hot water to the grist. So we take our crushed grain or barley, we add it to hot water. The carbohydrates in the malted barley is only about 15 to 20% sugars. The rest is starch. So we need to let the alpha and beta amylase do their job and convert those starches into usable sugars. So this is the same reaction that happened during malting process. There's still some of those enzymes alive and hanging out in the malt. Most of them were destroyed during the kilning process, but there's still enough there so we can reactivate these things and in this mash let them do their thing. So what happens in the mash? There's three things, or three steps. We have gelatinization. This is the breaking apart of the starches. Liquefaction, which is making those starches more soluble into dextrins, putting them into solution. And saccharification, turning the dextrins into fermentable sugars. So gelatinization, this is where we are breaking down the intermolecular bonds inside the starch, inside our melopectin or amylose. Water basically gets inside of the openings. It starts swelling. It gives more room for our enzymes to start doing their thing. It also helps to break apart or open up these the starches and help them to dissolve into the solution. Liquefaction is where the enzymes are breaking up the long chains into small soluble chains. So we're taking these very large starch molecules and we're breaking off some smaller sugars that are soluble. This typically happens between 150 and 160. So this is our alpha amylase working. And then during saccharification, our beta amylase is doing its thing. This is making fermentable sugars, specifically glucose, maltose, maltreose. So we have these two temperatures, two different temperature ranges, one for beta amylase, one for alpha amylase. This image is taken from Palmer's How to Brew Beer, and it shows you the overlap of the where beta amylase and alpha amylase work the best. So we can see here, this is the highest efficiency, the temperature you want for the beta amylase. It's around 142, 143, and then alpha amylase has its highest efficiency around 158. You can see though, down here, our alpha amylase is not really activated that much. It's not performing up to its full potential. So in this area, if we stay down here, we're going to get highly fermentable sugars. This is a slow process. It's going to take a while. We're not going to have we'll have very few long chain dextrins. the longer sugars. So it won't be it'll be a drier beer. It won't be as sweet. It'll be highly fermentable. When you read recipes, typically you're seeing things like mash in at 152, 153. That's this region. Anywhere between, say, 149 and 155, right here we have both the alpha amylase and the beta amylase activated and doing their thing. The higher the temperature for your mash in, the less the fermentables are there, so the fewer number of glucose, maltose, maltreose, and the higher the concentration of your longer chain dextrins. So out here, you get a sweeter beer. Here, you're going to get more fermentables. You can get a drier, crisper beer. So mash temps are very important. You have to think, what are you trying to achieve? Are you trying to get a crisp beer, a malty beer, something in between? If you're making a Scotch ale, you want a lot of maltiness, you might mash in a little higher. If you're trying to make something like a very light, extra pale ale, maybe mash in a little bit lower for a while and really convert those sugars to just fermentables. These are all personal preferences. So now that we have our fermentable sugars, our unfermentable sugars, the dextrins, we also have proteins in there. We need to convert, or we need to put these in the boil kettle. So we move our wort to the boil kettle. In the boil kettle, which is covered in a separate module, we'll be adding hops. We'll explain why we're boiling and the process that goes on inside the boil. So let's review. We have our malt. We mill. That makes grist. We put the grist in warm water, which is mashing in. We pick a temperature for mashing. You should understand why. And then we mash out. Mash out is the term for raising the temperature of the mash to approximately 170 degrees prior to moving this into the boil kettle, the wort into the boil kettle. This step stops the enzyme action and locks in your sugar profile. It also makes the grain bed in the wort a little more, it's less dense, so it can flow better. I'll post some readings, and please feel free to contact me by email for any questions.